Video, let's talk about a couple of new things that is in our plan for this semester. So the plan is to introduce the polynomial functions and discuss their degree, power function, real zero, multiplicity, turning points, and end behavior. What are these things? We will try to discuss. First of all, identifying the polynomial functions and their degrees. A polynomial function, if you just look, a polynomial function is, this is the definition of polynomial function. This is just only actually, you see the form of the polynomial function is a n x to the power n, a n minus 1, x to the power n minus 1, etc., then a n a naught or a 0. These are just only some numbers. X to the power n means, let's say, x to the power 4 or x to the power 5, some x to the power some power, then again some number, then again some power, x to the power something, then the power, this power is decreasing, then power comes to like this is x to the power 1 and then x to the power 0. These are the things. So you see a naught, a n minus 1, these are some numbers, and then these are the variable. This is variable, this is still number, just some different numbers. It's not necessary that it has to be like 5, 4, 3, not like that. It can be just different numbers, any real numbers, see. Just one very important condition is this n has to be non-negative integer. This is the main thing of polynomial functions. If you really want to care, this is the thing, non-negative integer. What does it mean? Let's see. Which one is polynomial function and which one is not, and what is the degree? Let's try to find out from here. So if you look at this, see, this one is just some number. This is minus, no problem, and x to the power 4. As I said, the power, this is the n there, the power has to be some integer, non-negative integer, and this is perfectly fine. This is what? This is 4. 4 is just some integer and it is not negative. So this a number is a polynomial function, and degree is 4. Degree is the highest power of some degree is the highest power of the function. And this one, b number, what is this? This one, the power is what? X to the power half, 1 by 2. So this is not integer. The power is not integer here. That means this one is not a polynomial function. And this one, if you will see, this is just some polynomial function. There is two function here. One is x square minus 2, another one is x cube minus 1. There is two function here, and this is in division form. Highest power is in the downside. This is not a polynomial function, because if you bring it up, if you take it up, then it will be negative power. This is not a polynomial function. This is actually a polynomial function, although it looks like something creepy, like only 0. This is called 0 polynomial. Just 0 is also possible. Okay, this is 0 polynomial, only 0, because this is not violating our definition. There is power is not negative number, power is not in decimal number, so no problem with the definition. This is 0 polynomial, this is called. And this is also actually, see, just some number, but no problem with our definition. So this is actually also a polynomial function, because x to the power here, x to the power 0. X to the power 0 means, that's why this is 1. So x to the power 0 is also no problem, because 0 is not a decimal, 0 is not a negative number, so this is fine. And this one is x cube ax minus 1 whole square. So you see, if you do the formula, then it will become x square here, and this is x cube. And if you multiply x square and x cube, you will find x to the power 5. And you see, this is power is some number, this power is also some number, so some integer number, non-negative integer number. So this is actually a polynomial function. And degree is what? This question, degree is what? Degree is 3 or 2. Actually, this question degree is 5. because if you multiply them, x to the power 3 and x to the power 2, then it becomes x to the power 5. So degree is the highest power of the of all the terms. Like if you have 5 terms, then highest power of the variable you must consider. So this is how we can identify the polynomial functions and their degrees. Identifying the graphs of a polynomial function. So in the polynomial function, the condition is the polynomial function will be smooth and continuous. This graph is smooth. Smooth. The graph is smooth. There is no corner. Okay, corner. Smooth means there is no corner in the graph. Very smooth. See, if I zoom it, you will see also. See, zoom, very continuous. So this graph is smooth and continuous, and in contrast, this graph is, see, there is some corner, there is some cusp, there is some gap, there is a hole. This is not a polynomial function graph. If there is hole or corner or some gap, this is not a graph of polynomial function. Polynomial function graph has to be smooth and continuous. This one, this one is a polynomial function. This one is polynomial function. This one is not a polynomial function. This one not a polynomial function. There is a corner here. There is a corner here. So not a polynomial function. Let's go to next one. Oh, power function. Let's discuss this. Power function means if we have this, our the power this is the variable. See, x to the power n, x square, x cube, x5, x10, like this. Power function is defined is a function of degree n of some monomial. Monomial means one term. Total, there is just only one term, and degree is n. N can be positive, n can be negative. That is the power function. A power function is defined by single monomial. Single monomial means just only one term, so that is a single monomial. And we have some, this is the graph of x cube graph. This is a odd power function, and I have x cube graph, and if the power is more, power is 9, power is x cube graph, and I have the graph of, I think the graph of x square also is there. This is the x square graph, and this is x to the power 4 graph. And notice that x square graph, what is the difference between x square and x to the power 4? See this. This is x to the power 4 graph, and this is x to the power 8 graph. See, x to the power 8 graph is growing little bit faster, and there is some a bit flat here near the 0, a bit flat, but both graph actually passes through 1 1 and minus 1 1 points, and similar behavior you will find here also. Similar behavior you will find here also. See this. So these are the power functions. Power functions, why will I need to discuss? Because these are useful while drawing the graph of polynomial functions. We need them. Zeros and multiplicity. Real zeros and multiplicity. What is real zero? Real zero is some number for which these functions will become 0. The value of this function will become 0, or the function will become 0. You can say that also. Look at this. If I put 0 here, what happens? 0 into this. So everything will become 0, right? That means for x equal to 0, the whole function is 0. Again, look at this. If I put here plus 2, then what happens? 2 minus 2 equal to 0. 2 minus 2 equal to 0 means the whole function is 0. That means x equal to 0 and x equal to plus 2, for this 2 value, my whole function is 0. That is why x equal to 0 and x equal to plus 2 is real 0 of this function. And what is the multiplicity? Multiplicity, we said x equal to 0 comes from here. See, the power of that thing is 2. That means multiplicity of that real 0 is 2, or multiplicity of this x is 2, and multiplicity of that real 0, which is plus 2, is 1. The power is here 1, that's why. And I have the graph of this function is this, and you can see real 0 means what? At x equal to 0 and at x equals to 2 plus 2, actually the function touch or cross the x-axis. Okay, see the x-axis at 2 and at 0, x equal to 0 and x equal to 2, we have the function is coming to that point. And let me tell you that this thing also, if the power is 2 or 4 or 6, any even number, then the graph will touch the x-axis. And if the power is 1, 3, 5, 7, 9, any odd number, then the graph will cross the x-axis. See, at this point, at plus 2, my graph is crossing the x-axis. For this function, this is another method. For this function, one real 0 is x equal to plus 2, and multiplicity for this term is 1. This one x equal to minus 3, multiplicity is 2. This one x equal to plus half, as it is minus half, so plus half will be the real 0, and multiplicity is 4. So this is how we can find out the multiplicity and real 0. Turning point and points and end behavior. Turning points is, you see the graph is there is two, turning, the graph is turning here. This is like some road, and this is a corner of some road, turning here. This is not corner actually, as it is continuous, so we cannot say it corner, but just to just as a comparison, so we can say, see, this is some kind of turning. This is some turning. So how many turning in this question? How many turning? See, 1, and then again another 1, 2. So we have 2 turning here. And the turning point is actually, if f is the polynomial function of degree n, then the graph f has at most n minus 1 turning points. That means if the degree of a function is n, let's say degree of a function is 5, then that function will have 4 turning points maximum. Okay, it means what? This is actually the graph of this question. This is the function. So this is the graph. What is the degree of this question? Here is 2, power is 2, and here power is 1. So 2 and then 1 together, power is 3. So power is 3. So degree of this question is 3. That means if the degree is 3, then for this question maximum turning point will be how much? Maximum turning point will be 2. If the degree is 3, maximum power means degree. If the degree is 3, then turning point will be 2. If the degree is, let's say, 5, then the turning point will be 4. 1 less always. If the maximum turning point we are talking about, if the degree is 10, then maximum turning point will be 9. 1 less always. So that's it. And end behavior is what? End behavior is, this also depends on the maximum power, and behavior also depends on the maximum power. This will be the maximum power, x to the power n, a n x to the power n. So actually in the graph, the end part is this one and this one. This is the end part. This portion here and this portion here depends on the maximum power n, not the other terms. There are many terms here, but the end part will depend on the maximum power. So what is the maximum power of this question? Maximum power, as we said, maximum power of this question is 3. So you see, if you remember our if the power is 3, then our graph was like this. like this. That's why the end part is like this and this part is like this. This is due to the maximum power. Let's say if the maximum power is 4, then the graph will be different. Then this power will go there and this part will also go up, because even power means this graph. X square graph is this, but this is 3. Power is 3. That's why this line is coming down this side. This line is coming down, coming up this side. This is called the end behavior. This part is called the end behavior, and it depends on the maximum power. So this is the end of this lesson. I hope it helps in some way. Thank you all. Thank you very much. Bye bye.